Alright, so in today's video we're going to be talking about the skill of lines, angles, and triangles for the SAT math section. So just like jumping into the first question here, we're given the following information. The figure AC is equal to CD. The measure of angle EBC is 45 degrees, and the measure of angle ACD is 104 degrees. What is the value of x? So we're just going to write down the following given information. EBC is 45, and ACD is 104. And since AC is equal to CD, the triangle ACD is an equilateral triangle. And basically what this means is that it has two angles that are equal to each other. And since 104 is greater than 90, we know that C cannot be one of these two angles. Therefore angle A and angle D are the equal angles in the equilateral triangle. So to find out the value of D, or really just the entire triangle, of both D and A, it's going to be D, 104 plus D plus A is equal to, well, since all triangles add up to 180 degrees, it's going to be 180 degrees. And that's according to triangle sum theory. And then of course D is equal to A, so you can really express it like 104 plus 2D is equal to 180. Subtract both sides by 104, you get 2D is equal to 76. Divide both sides by 2, you get D is equal to 38, I believe. Okay, so on to the next part of the question. We know now that 38 is the value of D for angle D. And then we're going to use the same triangle angle sum theorem, to find out the value of E. Because we already know that 45 is B and 38 is D. So to find E is just going to be 45 plus 38 plus E is again equal to 180. Triangle angle sum theorem. Subtract both sides by 45 plus 38, you get E is equal to 97, I believe. And then finally, the last main idea from this topic, from this question rather, is going to be collinearity. Since angle E and angle X rest on a flat line, the sum of their angles is going to be equal to, again, 180 degrees. So we can express that like this: E plus X. Of course, we already know E, so it's just going to be 97 plus X is equal to 180 degrees. Subtract both sides by 97, you get X is equal to 83. And that is the correct answer. So on to the next question. We're going to be talking about similarity this time. And it gives us the following information. In the triangle ABC, the measure of angle B is 90 degrees, and the BD is an altitude of the triangle. The length of AB is 15, and the length of AC is 23 greater than the length of AB. What is the value of BC over BD? So we're going to draw out the triangle ABC. And then there's an altitude BD. And since B is a right angle, because it's 90 degrees, the two triangles that are formed from this altitude BD are going to be similar to the original triangle from which the altitude was formed. That sounds really complicated, but really all this really means to say is that this triangle is similar to this triangle. You know what I mean? Anyway, since angle D and angle B are equal to 90 degrees, they're going to be corresponding to each other in the formula. And since angle C is the same in both triangles, they're also going to be corresponding to angle C in both formulas. So to write out the formula, triangle ABC is going to be something, D corresponds to B, so D, and C corresponds to C, so C. And then since B has to go somewhere in the equation, it's going to be triangle ABC is equal to triangle BDC. Okay, so that's the hard part out of the way. Now it's the simple stuff. So to find BC, you're really just going to find AC. And to find BD, you're really just going to find AB. So we're given that AB, so you can write it like this. AC over AB is equal to BC over BD. And we're given that AB is 15, so that's going to be over 15. We're given that AC is greater than 23 greater than the length of AB. So that's going to be 23 plus 15, which is equal to 38 over 15. And therefore D is the correct answer. Alright, so for the next question, we're talking about similarity a little more. So, in triangles ABC and DF, angles B and E each have a measure of 27 degrees, and angles C and F each have a measure of 41 degrees. Which additional piece of information is sufficient to determine whether triangle ABC is congruent to triangle DEF? So it says, since they have two corresponding angles, ABC and DEF are similar to each other, but not necessarily congruent. When you have two angles that are equal to each other, in order to prove congruency, you only really need to prove that one side, one of the corresponding sides on one of the triangles, is equal in value to the corresponding side on the other triangle. So let's say EF is equal to BC, then the triangle is congruent. But the inverse logic applies as well. If EF is not equal to BC, then the entire triangle is not congruent. Therefore, under this logic, you only really need to look at two corresponding sides in order to determine congruency. Therefore, C, the lengths of sides BC and EF, is the correct answer. Alright, so for this question, we're given the following information. Big wall of text, very scary. The right triangle ABC, angle C is the right angle, and BC is equal to 162. Point D on side AB is connected by line segment with point E on side AC, such that line segment DE is parallel to side BC, and CE is equal to 2AE. What is the length of line segment DE? So that's the logic process. I'm just going to write a triangle to start off with. So ABC, and then BC is equal to 162. I did not write this correct. Okay, whatever. Okay, okay, wow, I really wrote this incorrectly. So C is the right angle, and you have A and B, and BC is equal to 162, so like this. Then point D on side AB is connected by a line segment with point E on AC, such that line segment DE is parallel to BC, and CE is equal to 2AE. Therefore, there's going to be a right angle here. So D is rests on AB, and E on AC, and CE is equal to 2AE. So that's kind of interesting, actually. As you can see, CE, so this, and AE is equal to AC, but CE is equal to 2AE. So that really means 3AE is equal to AC. Therefore, AE is equal to 1/3 AC. And since these triangles share two angles, 90-degree angle and also angle A, ADE is congruent to ABC. So therefore you can compare them with a ratio. In this situation, a ratio of 1/3. So in order to find the corresponding line segment of one triangle, you would simply have to look at the corresponding line segment of the other triangle and then put it through the ratio, which is very convenient because it's asking for DE, and the corresponding line segment on ABC is 162 BC. So dividing 162 by 3, you get 162 divided by 3 is equal to 54, which is equal to DE, and that is the correct answer. Alright, so for this question, we're going to be talking about right triangle area. It gives us the following information. The area of triangle ABC above is at least 48, but no more than 60. If y is an integer, what is one possible value of x? So the area of a right triangle is going to be 1/2 base times height. We know that the base for ABC is going to be 5 plus 7, so that's 1/2 12h. That's going to be 6h is less than 60, but greater than 48. Divide all sides by 6, you're going to be left with h is equal to, well, could be greater than 8, but less than 10. So I think a very obvious answer would be 9, but there are more options, and I'll talk a little bit more about that later. Anyways, just assuming that h is 9, we can compare ABC with the smaller triangle here because they are actually similar to each other. This is because they share two angles, the 90-degree angle and also the angle A. Therefore, you can write a ratio between these two triangles like this. X over y is equal to the base of ABC, so, well, actually the base of the smaller triangle, so that's going to be 5, over the base of the bigger triangle, ABC, so that's going to be 12. And we already know that h is equal to, well, the height, which is y, which is 9 in our situation, so you can rewrite it like x over 9 is equal to 5 over 12. Multiply both sides by 9, you're going to be left with x is equal to 45 divided by 12, or 15 divided by 4. And this is just one of 3 possible correct answers. The other ones I'm going to show you in a sec. The top right corner. If you got a value that's equivalent to any of those 3 answers, you got the answer correct. Anyways, that's about it. Alright, so for this question, we're going to be talking about parallel angles. So we're given the following information. The figure LQ intersects MP at point R, and LM is parallel to PQ. The lengths of MR, LR, and RP are 6, 7, and 11. Respectively, what is the length of LQ? So just filling out the information we're given to us. MR is equal to 6, LR is equal to 7, and RP is equal to 11, sorry. So then we also have that LM is parallel to PQ, and since they're vertical to each other, this means that these triangles are similar to each other, but not necessarily congruent. And specifically they're vertical, therefore this triangle is going to be a weird inverse of this triangle, if you know what I mean. And basically you just have corresponding angles where the top side corresponds to the bottom side of the other triangle. It's kind of weird. Anyways, to find the length of LQ is just going to be, well, first you have to find the ratio, right? So it's going to be PQPR is equal to something, the perimeter of RLM. I actually don't know the name of the triangle, I'm just guessing. And so to find that, you have to find the corresponding angle for QPR. That's going to be 11 RP, and then the corresponding angle, so that's going to be 6 RM, so it's going to be 11 over 6. So the perimeter of QPR is equal to 11/6 the perimeter of RLM. So in order to find a side for QPR, you just have to take the corresponding side from RLM and multiply it by 11/6. So for example, LR corresponds to RQ, therefore RQ is equal to 7 times 11 over 6. So to find LQ, you're going to take LR plus RQ. That's going to be 7 plus 77 over 6, which is equal to 119 over 6. According to my calculator anyways. Which means that D is the correct answer. And that's about it actually. Thank you for watching.